tutorial is going to be a very brief one because I don't want to take much of your time. And it's centered around learning how to use Google Sheets to estimate correlation coefficient and also analyze the data as far as regression and correlation analysis is concerned. And I'll also try and see if we can introduce us to test of hypothesis, just the basic knowledge of test hypothesis. And at a later date, we will build on the knowledge that we are going to be acquiring today. So quickly, let's dive into what we have for today. Now, this is a data set for you that was collected from a particular source. So if you have this kind of a data and you want to get the regression, you want to fit the line of best fit, and you also want to get the correlation coefficient. How do we go about it? Let me just say a brief thing about correlation and regression. Correlation is a measure that we use in statistics to determine the relationship between two variables, whereas we use regression to model a particular equation that will suit the data that you are working with. If, for example, you have two or more data, in this case, we are focusing on just linear regression, meaning that our focus will be on two variables only. So if you have more than two variables, we can also fit the line of best fit for such. But in this video, we're looking at just a simple linear regression with two variables. Now, how do we go about modeling equation when we have two variables? First and foremost, you need to understand what we call dependent and independent variable. As the name implies, independent variable is practically a variable that does not really rely on another variable, which means that the outcome of that variable is practically not determined by another variable, whereas a dependent variable is that kind of variable that depends on another variable to get its outcome. So for instance, in this particular information, and that's why you need to understand the kind of data you're working with. Now, this is price based on region. This latitude and longitude signifies the region. So obviously, price will be dependent on the region. So the region might not actually, be dependent on the price. But in contrast, price is dependent on the region. So meaning that price is our dependent variables, I beg your pardon, whereas latitude is our independent variable. So how do we now fit a line of best fit, between these two variables? It will not always appear to be, perfectly linear, but then that's what we call a line of best fit, meaning that there will be some outliers. What we mean by outlier? There will be some points that will fall outside the region. So in order for you to fit a line of best fit between these two variables, all you just do is select the first variable that you are working with, then hold Control if you are using a Windows system. Then if you are using a Mac OS, it should be Command on your system. So then you click, with that Control being held down, click on price. Then having done that, you go to your insert and insert chart. Now, by default, you have something like this. So we just have to come to our right pane where you have line chart. Click that drop down, then you select the scatter plot. So this is our scatter plot. However, we are not just interested in getting a scatter plot. Of course, we understand that scatter plot is actually part of what we do when it comes to regression analysis. But we're also interested in getting the line of best fit. So how do you get that? At your right pane, if you can't get this chart editor, all you just click on these three dots that you have here, then click on edit chart. Automatically this will pop up. Then you go to your customize, then click on series. You come down, click on series. Then from there, you go to your format data point. Then you can click on trend line. Automatically, your line of best fit will pop up. Then from there, you can decide to do other customization, select the color that you are most interested in. But in my own case, color is not so important. Then the next thing we want to do is we don't just want to fit the line of best fit. We also need to get the equation that governs this particular variable, such that if we want to predict the price based on a particular region, or just get the latitude of that region, then we can insert the value of that latitude into the equation, then the price will automatically be reduced. So how do we go about that? you just need to go to label under this, still under the same tab that you have. Go to label, then click on use equation. Use equation. So automatically the equation will come up on your chart. So this is actually the equation that that connects the price with 32. Now this equation signifies so many things, and in a moment we're going to be analyzing what that equation signifies. Also, in regression, we also talk about coefficient determination, which is r squared. So I also need this r squared, so I'll check that box, r squared. Now what does this r squared mean? I'll explain to you in a moment, so please don't go anywhere. Now that we have been able to fit our line of best fit, we have our equation, that's our regression model, and we also have our coefficient of determination, which is our r squared. What does these old jargons mean? Now the first thing you need to know is that the coefficient of your dependent variable, which is your x, is actually the gradient of this particular chart that you have. Gradient is simply a slope. And what does that signify? That means that if you are having a positive gradient, that means that your graph is a positive graph. And what that means in correlation and regression is that if your gradient is positive, it means that the relationship between your independent and dependent variable is actually a positive one. Meaning that as the value of one increases, the value of the other one also increases, and vice versa. As the value of one decreases, the value of the other one also decreases. So which means that the two variables, they have positive correlation. You need to take note that the value of your gradient, meaning the coefficient of x now, the value of your gradient can only show you whether there's positive relationship or negative relationship. However, that value cannot actually tell you how strong that relationship is. Hence, the reason why we need this r squared. So even if, no matter how high the value of that coefficient is, it can only tell you whether the correlation is positive or negative, which implies that if it's positive, as the value of one increases, so in this case it is positive, so as the value of price increases, the value of the latitude also increases, and also as the price decreases, the latitude also decreases. But then with that line of best fit alone and the equation, we cannot actually deduce the strength of the relationship, and that's why we actually need this coefficient of determination, which is our r square. Now that r square, what does it mean? Your r square simply tells you how strong your relationship is. So how do we determine that? Let me come out from here, and now you can get your r square is, you get your correlation coefficient and square it. I don't need this anymore, but let me just show you how we can get our r square. We can also get correlation coefficient by just using the Corre function in Google Sheets. So just type equals, then we have Corre, which stands for correlation. So Google Sheets automatically bring up the option. Here we are dealing with person product moment correlation coefficient. Also, we know that we also have rank correlation, so we can also use rank correlation coefficient to determine all of these things. But in this case, we are talking about product moment correlation coefficient. So we just click on that. Now, the first range of value that you put must be your dependent variable, which is your y. Independent variable. So we'll close that bracket and click enter. So this is actually your correlation coefficient, which is r. We denote it as r. So your r square, but that's by calculation anyway, your r square will then be, so we have r square, the square of r will then be just to square this. We come here, we square this, so we have the square of this value will give us our r square. Now this is our r square. So we can decide to just approximate this to 2 decimal place. What do? Just come to this top pane. You keep clicking this arrow until you have the number of decimal places that you want. So select the cell. You want to decrease the decimal places. So keep clicking until you have the number of decimal places that you want. You can see that approximately we have 0.01 as our correlation coefficient, which is the same thing as what we have when we use this chart. Now, what does this signify? I would rather prefer this to be in percentage, so I'll click on the percentage icon that we have on the top pane. So meaning that we have 0.99% as our correlation coefficient. What does this signify? This is just less than 1%. It implies that 1% of the change, listen and listen very carefully, 1% of the change in your x, because your x is dependent on y. I mean, your y is dependent on x. 0.99% of the change in your y is dependent on x, not vice versa. Now, let me take it again. 0.99% of the change in y is actually dependent on x. Now, when you subtract 0.99 from 100%, then you get 99.01. Yes, 99.01. Let's do that calculation. We have equals to 100 minus this. So you have, beg your pardon, there's a mistake there. Percentage. So let's do 100 minus 0.99. So I don't want that to be percentage. Let me just change it to number. So that's 99.01. So this means that 0.99% of the change in y is dependent on x, whereas 99.0.1% of the change in y is dependent on other factors. What does that tell you? The lower your correlation coefficient, the weaker the relationship between your variables. So in this case, we can say that the two variables, they have almost no relationship, because this is actually very small. So please take note of that. Your correlation coefficient determines how strong that relationship is. If it is small, then that means that the relationship between those variables is very weak. So in this case, they have a very weak relationship. That's number one. Another thing to take note of is that positive correlation coefficient signifies that the two relationships, they have positive relationship, meaning that as one increases, the other will also increase. And as one decreases, the other will also decrease. And in contrast, negative correlation coefficient only signifies that the two variables, they have negative relationship, which means that as one increases, the other one will decrease. And as the first one decreases, the other one will increase. But that does not mean that if, for example, let's compare two correlation coefficients. If you have correlation coefficient 1, let's call it R1. Let's call it R1 is a minus 0.95. And another correlation coefficient we have R2. That's 0.60. This is 0.95 and the other one is 0.60. Now, if you have to compare these two correlation coefficients, naturally speaking, you will say that R1 is, lesser than R2. Mathematically speaking, 0.95 is lesser than 0.6. But in natural sense, in correlation, we can say that that data set that gives us minus 0.95 as a correlation coefficient has weaker relationship compared to this. Is not true. Your negative only signifies that there is a negative relationship. It does not actually mean that that negative relationship makes that data set, weaker compared to the other one. What I'm saying in essence is that this particular one, this first data set that has negative as, the correlation is only saying that those data sets, they actually have a negative relationship, meaning that one increases and the other one decreases. But then their relationship is stronger compared to this other one that is positive. How do I mean? If you find the R square from here, of course, you know that R square is gotten by squaring your R. If you find this R square, because that's the only way you can determine the strength of relationship. Square of this, let's square 0.95. If we square this, we arrive at, let's change the percentage, 90.25. Also, if we square this, let's square 0.6, we arrive at, we arrive at 36%. 86%. Now you can see that the first set of data actually portray a stronger relationship than the second set of data. So in a nutshell, we are saying that the fact that the correlation coefficient is negative does not necessarily mean that the data set is, weaker in terms of relationship compared to the one that has positive relationship. So forget about negative sign. It only tells you, the direction of relationship, whether it's negatively related or positively related. And that's that on that. So, and there's something that you need to also know when you have a data set. We can also talk about some regression metrics that you need to understand in analyzing regression and correlation problem efficiently. One of them is mean absolute error, which is MAE, and that one is mean square error, which is MSE, and that one is root mean square error, which is RMSE. All of these things, at a later date, we'll talk about them in depth. But the only thing that, as it stands now, you need to understand is that each time you have a larger value for all of these metrics, it only signifies that the deviation from the true, because everything that we are doing here is about prediction. So it means that the deviation from the true value is larger. If your MAE is 2 units, for instance, it means that the data set deviates from the true value by just 2 units. So if it becomes 10 units, it means that the data set deviates from the true value by 10 units. The same thing applies to the other ones. So now, if you're having a larger error, all of them, they are error. If you're having a larger error, your data becomes less accurate, because all these metrics, they actually measure of accuracy. So the larger the value, the lesser your accurate. The weaker your accuracy. And the lesser the value, the more accurate analysis you have. And finally, on regression model, I want to also show you that when you will plot, the other time we plotted our graph, look at it here. This is our line of best fit. You can see that the line is just, one straight line, and we have a lot of points that falls outside our line. All these points, we call them outliers. They are outliers because they are so far apart from the line of best fit. Now, when you see a chart of this nature, look at these three charts that we have. We say this is underfitted, the first one. This is good fit or perfectly fitted, and this is actually overfitted. Overfitted in the sense that we don't actually have a clear trend. However, we just decided to just join the points in the manner that most of the points that we have will be connected. That's why you see it is overfitted. So you need to know that even though it is overfitted, if we try to fit a line of best fit for this particular data point, we will not still be able to get a robust analysis. So it's overfitted. You need to understand that overfitted point will most of the time not be able to have a good fit when it comes to line of best fit. So you need to understand that. So that's just what you need to know.